Mute on.
Hello, everyone, and thank you for joining us. We welcome you to FusionStorm's Expert Series and, of course, to today's webcast on cybersecurity. Our panel will be addressing a topic titled Lateral Attacks, What Are They, and How Should You Handle Them? But before I hand things over to our host from FusionStorm, please do allow me a few quick housekeeping items. Number one, today's webcast is being recorded. It will be available for playback. As part of the ongoing Expert Series, all registered attendees will receive a follow-up communication, and that includes a link for review. Please do note that all of our participant guest lines have been muted, and so we would ask that during our scheduled question and answer segment that you please use the Q&A window as part of the event system. Now, with that in mind, let me hand it over to FusionStorm's Engineering Director, Rich Bailey.
Hi, thank you, Kevin. Appreciate that, and good afternoon, everyone. It's my pleasure to welcome you to first in a series of VMware and FusionStorm Expert Series webinars. Today we're going to talk about a topic, as Kevin talked about, lateral security within a virtual environment. My name is Rich Bailey. I'm the Senior Engineering Director for FusionStorm, and as part of a global integrator, we visit customers, we visit multiple customers on a weekly basis. And one of the primary concerns that those customers have is the current security environment that they're seeing and the actors that are involved in that and the comprehensive solutions that could be available to them in order to prevent the unfortunate occurrences that we see on a daily basis. That said, FusionStorm and VMware have been working together to develop comprehensive solutions to address these. And it's my pleasure to introduce a gentleman named Jeff Wilmington. Jeff is a Senior Technical Product Manager with VMware Networking and Security, the business unit there. And he covers all the security aspects and functions of the VMware NSX product. And Jeff has been with VMware for 2.5 years, has worked in the industry for more than 17 in various roles here. So with that said, and without further ado, I'd like to hand it over to Jeff. Jeff, thank you very much. The ball is yours.
Awesome. Thank you very much. Appreciate everyone's time today. Hope everybody can see the PowerPoint. Everybody's all good. So today we want to talk a little bit around data center security and around basically containing lateral attacks. It's a topic that's come up rather recently. Most folks are fully aware kind of breaches that have occurred in the media and so forth. And so what VMware does in terms of, from a security perspective, is we've been building out a product called VMware NSX, which has several different use cases, one of those being able to help with what we refer to as, network least privilege or zero trust policies within the data center that can help some of our customers, reduce the attack surface from some of these lateral attacks. So kind of the first thing I want to dig into here is, just a little bit of a recap and the reason why, kind of what we're, the reason why we're pursuing a lot of this, right? And that the average cost of a data center outage is somewhere around $750,000, and that's been reported by Ponemon, et cetera. And that, lots of organizations, it's not a matter of when, it's not a matter of if, it's a matter of when those organizations, could fall prey to, one of those attacks, if you will, within the data center. And that, the information that actually exists within the data center is becoming even more and more valuable. If you take an example, let's say a healthcare organization, you take the Ponemon Institute's recent documentation in terms of what a medical record costs on the black market, a healthcare record, it actually can be anywhere between $350 and $400 per record when those records are stolen, because those are much more valuable, if you will, than say like things like credit card data. So it's not a matter of if, it's a matter of when, and that organizations need to protect that data within their data center as much as possible. So as we take a look and see kind of, a little bit around why breaches are, still such a problem, and it's, we've done a really, really great job of protecting the perimeter. We put, massive firewalls at our perimeter of our networks, and those firewalls are not, it's not like they're not doing their job. But the problem that exists is that, once you get through that data center or get through that perimeter firewall, being able to move horizontally, or what we refer to as east-west within the data center, is actually very, very easy, because typically the security posture, the security protocols, and policies that are in place inside the data center are either non-existent or they're very, very difficult to actually operationalize. And once you're through the perimeter firewall, the first thing that usually an attacker goes for is they try to find the low priority systems, right? Those systems that people don't usually keep an eye on, or those systems that are very easily misconfigured or don't have a lot of security around those. And they attack those systems first, and then they privilege escalate up so that they can start moving around within the data center. And then once that one low priority system is actually targeted and privilege escalation actually occurs, and then attackers start to move laterally within the data center, what ends up happening is that usually those low priority systems, there may not be any security controls between that system and, say, your HR database or your CRM system or your ERP system. So with no security controls basically lateral, it's very easy to compromise the low priority system and then start figuring out how to compromise systems from an east-west perspective. And then once the attacker has continued to proliferate out from an east-west perspective, they just continue to move on within the data center. And they continue to gather and kind of exfiltrate data over over weeks or over months. There's been some studies around how long attackers have actually been within data centers. And I remember so I come from a healthcare background within VMware, but one of my healthcare customers had, or not one of my healthcare customers, a healthcare customer had actually been, they'd actually had someone in their system for several months before they were able to actually find those, that those systems were basically compromised. So, how do we actually go through and help from an east-west perspective? So, this idea of a secure application infrastructure is critical, right? So, if you, kind of our traditional ways of doing things are to, place physical firewalls between our workloads and, try to create rule sets between our applications from one app to another or from one workload to another. The issue with the, leveraging physical firewalls is, one, it becomes extremely expensive. Those perimeter firewalls that you're buying are hundreds of thousands of dollars. The other firewalls that you may buy to actually prevent traffic between one VM to another VM, that physical firewall could be, another $50,000, $70,000, $100,000 as well. A very, very expensive piece of hardware. And you typically have to buy more than one. And then having someone that's able to actually operationalize that, right? Because if one application needs to talk to another, I need to write this rule. And, oh, we just built this new application, and now this system is sitting in here, so I need to write another rule for this application to actually be able to communicate. So it becomes extremely complex with how you're able to actually operationalize the systems. And then the other thing that we've started to see is we see these service virtual machines or these firewalls that you can actually install in your hypervisor, right? So the firewall vendors have virtualized their firewalls, and we've put those firewalls, if you will, into onto the host itself. The issue kind of with that from that perspective is around those virtual firewalls. If you think about it, they are constrained by the constraints of a virtual machine. So virtual machines have a finite amount of throughput, and they have a finite amount of resources. So they could be slow. If you have a lot of east-west traffic, the virtual machine, these virtual firewalls can only do 1 or 2 or 3 gigabits per second between the firewalls. If you need more than that, then you have to shuffle your workloads around so that you can get to the constraint of the bandwidth that's necessary for that virtual firewall. And it becomes extremely complicated because now I got a firewall here. Again, it's the same kind of concept, if you will, from the physical firewall perspective, except all we did was we put it onto the host itself, the vSphere host or whatever, and now we have even more firewalls, if you will. So what we want to, what VMware has kind of come back with in terms of, the secure application infrastructure is it starts with virtualization, right? So if we can, take a security posture that abstracts the underlying infrastructure from the applications running on top of it, then that makes things much, much easier for customers to adopt. We know that customers have multiple different levels of network, topologies and security postures and et cetera, and that it's, having to build a custom-built security policy for each organization is extremely difficult when you're dealing with hardware-based appliances and so forth. It becomes very operationally complex. And then when you have a secure application infrastructure, we need to understand how those systems talk to each other and talk to themselves, right? So if you think about an application, say a 3-tier application, it has a web server, an app server, and a database server, that the end user actually comes in and talks to the web server. We refer to that as kind of north-south traffic, right? This is client-to-server communication. But that the web server has to make a communication or a call to the app server for some business intelligence, and then that app server has to make a call to the database to actually get the information back. And if you think about it, 66% of the actual communication is actually happening between the servers on the back end. Less communication is actually happening from the end user to the web server. So if there are no controls, from the app server to the database server or web to app, then, how do we actually know how those systems are actually talking to each other? And we have tools now that can actually show you or show an organization, the full visibility of how applications within the data center actually talk to each other. And we're going to talk a little bit about that in terms of a product we have called vRealize Network Insight. And I was going to show you a little demo towards the end here just to kind of show what we are able to see from a visibility perspective. And then, the secure application infrastructure needs to provide that ability to use microsegmentation to compartmentalize applications. So if you're actually thinking, we talk about zero trust, right? So zero trust is a Forrester term. Zero trust essentially means that we assume that everything is a threat and we act accordingly. And a zero trust architecture, security architecture, is very synonymous with network least privilege. And if you're a security folk, if you're security people, you know what the concept of least privilege is. The concept of least privilege is to only allow the actions that are necessary for something or someone to perform the minimum number of permissions to do their job. And so when we talk about that from an application perspective and a network least privilege, we only want to allow the ports and protocols that the application needs to communicate with itself or to the outside world, and only allow those ports and protocols. So when we do that, we significantly shrink the attack surface of how an attacker could actually move laterally within the data center. So this significance of microsegmentation, this is the term VMware came up with in terms of what we're actually doing or how we're achieving zero trust or network least privileges around microsegmentation. And that what we're functionally doing is, and I'll show you here in just a second, is we're actually placing a firewall into the vSphere hypervisor itself. This is a kernel module that actually exists inside the vSphere hypervisor and provides a firewall, a stateful firewall, to every virtual workload that actually exists on those hypervisors. Which means that now we're able to create finely grained communication and security policies for one virtual machine to another, regardless of where they sit. If a virtual machine sits on the same host as another machine, we're able to actually go through and actually create a policy that says these two machines can't talk to each other. If they sit in a different data center, we can even do that as well. So the concept of leveraging virtualization means that those firewall policies can now move as our workloads move within the data center. And if you want to think about it in terms of, let me back up a slide here. But if you see this, you kind of see that patch cable there in the background with the lock on it. Functionally, what we're doing is we're actually, if you think about that lock, we're taking a physical server, if you will, and the cable, the patch cable that would come with it that plugs into a switch, and we're putting a firewall, or where that lock is, we're putting a firewall right in the middle of that patch cable from a virtual perspective, which means that we can control in and out traffic without ever having to leave the hypervisor itself. So what we're able to do is, that's going to reduce the overall application infrastructure attack surface, and it can effectively prevent, security threats from basically moving laterally within the data center. And these concepts, scale from, secure user environments, so VDI desktop systems. If you actually think of security around virtual desktop infrastructure, those virtual desktops now exist within your data center. Technically, they exist east-west or adjacently to other workloads in your data center, server-based workloads. And maybe on a different network or something along those lines, but they technically still exist in your data center. These are desktop operating systems, and we all know that desktop operating systems tend to get compromised, on a daily basis, or it depends on whatever an end user actually goes out and does. But with NSX and having a virtual firewall, if you will, if you take this concept here of the virtual machine with the firewall icon on top of it and think of it as a VDI workstation, we can actually prevent the desktops from ever talking to each other with very simply by saying that these sets of virtual machines can't talk to these virtual machines. And if you think about that in terms of like VDI desktop systems and so forth that have thousands of desktops running within the data center, we no longer need to know the IP address or the MAC address or any of those types of things that we had to know in the physical firewall world for actually doing this with NSX. We can actually leverage vSphere constructs or vCenter constructs and say these virtual machines can't talk to these virtual machines. Another kind of use case here is around virtual DMZ and our ability to secure the demilitarized zone between for web applications. So typically within a DMZ you might have multiple web servers for an application. If one web server is compromised, it could easily spread from one system to another because typically those web servers are built in the exact same fashion. So if one is compromised, it's very easy to move laterally. With NSX, we can actually, regardless of what network that these systems sit on, even if they sit on the exact same network, we can say the web servers can't talk to the web servers very, very easily, which means you may be able to get to one, but you won't be able to get to the others because they're not allowed to talk to each other, which means that we're effectively kind of shrinking that attack surface. So I'm going to move on just one here and just basically get to kind of the NSX portion of this because I want to get to kind of the technical aspects. So the NSX customer use cases here, we have 9 kind of different use cases, if you will, for the NSX product. And obviously we're focusing on the security section here, but just want to let folks understand that while we are talking about security and containing kind of lateral attacks, that NSX is more than just a security-based platform. This is a platform that does network virtualization and other things as well. But as we focus in here, we kind of had a discussion here on the microsegmentation and the DMZ Anywhere and kind of the secure end user piece. So these microsegmentation, these privileges, the things that we need to do to actually achieve microsegmentation is we need to actually provide isolation. So if we have a dev network and a test network or production network, these are completely isolated systems. And if you take that in terms of what a network is actually built out for, these might be different VLANs, or they might be a private VLAN or anything along those lines. There's typically going to be a firewall in place between these systems so that no communication can actually happen between these networks. And then we have segmentation, right? So we're doing isolation, basically saying these networks cannot talk to each other. Then we're doing segmentation, basically saying that the workloads that exist on any of these networks, we're only going to allow these systems to talk to each other from a segmented perspective. We're going to segment out our web servers and our app servers and our database servers, and we're going to control the communication path within that network for that application. And the last kind of concept here is around service insertion. So I explained before that we're putting that firewall, if you will, between the virtual machines. That firewall that exists within NSX is a layer 2 through a layer 4 firewall. So this means that I can do things like on source IP, source port and protocol, destination port and protocol, etc. 5-tuple rule building. If I need to go higher for east-west traffic, the NSX platform is flexible, means that, and modular, means that we have the ability to integrate, and we do have integrations with several firewall vendors, virtual firewall vendors, to actually perform what's called service insertion. So if we need advanced-based services, so deep packet inspection, IDS, IPS, etc., those systems can actually plug into the NSX platform, and we can actually steer specific types of traffic to those appliances for deeper inspection as necessary. And this is functionally what we're doing here. We're saying that each virtual machine can now be its own perimeter. Because if the finance system wants to talk to the HR system, we can actually block any one of those systems from talking to each other just by simply grouping those systems together and not allowing any communications between them. Very, very simply. And that we can also, the nice thing from an NSX perspective is, the NSX manager talks to the virtual center server of the infrastructure, which means that that virtual workload could be a web server, could be WebVM1, WebVM2, whatever, and we can actually use virtual machine names to write our policies. So we don't have to remember the IP address or the MAC address of those systems. We can actually say that VM1 can't talk to VM2 very, very simply. Or we can group systems together and say these systems are part of the HR department, or these systems are part of the engineering department, and actually provide isolation and segmentation between those groups of systems very, very easily. This means that you could have your HR system talking, sitting next to a web server, if you will, that exists, with outside access, and without explicitly allowing communication between those systems, they will never talk to each other. One of the other key features of what NSX does is around this grouping mechanism, right? So I talked a little bit about, how we actually group some of these systems together, and we're able to actually do lots of really, really granular types of grouping for the systems. So if you have workloads that are based on specific OS types, so customers, having Windows, so we have customers that have Windows Server 2003 boxes and Windows 8 systems, et cetera. And if you're actually trying to provide kind of, east-west security, if you will, between those systems, it becomes very, very difficult to do that simply because, I need to know all the IP addresses for a physical firewall, et cetera, et cetera. But from an NSX's perspective, we can actually say if the operating system matches a specific type of operating system, we can actually place those systems into a security group and immediately start to provide security posture around those systems. So we're able to actually control who talks to those systems and how those systems talk to each other very, very quickly, which means the spread, if you will, of attacks from an east-west perspective is, again, shrink down from a lateral movement perspective. And then we're able to, actually allow these systems to move within the data center. So if you think about things from disaster recovery, we still want to be able to provide security even from an east-west perspective, we still want to provide security from there. So if you're, running production workload or you're running disaster recovery, the ability to do either of those things and still have secure workloads from an east-west perspective, we're able to do that as well. So the big question, that a lot of customers say is, this is fine and great, and we're happy that you can help kind of provide that east-west security, but we don't even understand how our applications talk to begin with. What can we do to actually go through and actually, figure out how our systems talk? Our application owners, sometimes they know, sometimes they don't. Even the vendors sometimes don't even understand kind of technically how their applications may work. So in brownfield environments, right, or even in greenfield environments, as you have organizations with hundreds to thousands of applications, it becomes very difficult to try to figure out all the interdependencies, if you will, of an application. So what VMware has done is, and I'll talk about this a little bit later, is this concept around the virtual network assessment, and this is leveraging the VMware, the vRealize Network Insight tool to actually provide kind of this information back to a customer. So this is a system that actually is installed by the partner with the customer, and then a report is actually printed out, basically giving you some information around how the systems are actually talking to each other over what working protocols. And I'm going to get into just a quick demo here in just a second around VRNI itself, and actually show you how we're able to see the flows between the systems and actually start building our firewall rules or our east-west traffic isolation and segmentation for those apps very, very quickly. But this is kind of the information that you're going to get as you go through and start actually doing microsegmentation planning within your environment. So I'm going to kind of pop over here just for a second here. I'm going to pause my screen as I switch over to my other application here. So give me just a second. And we should be able to see my browser window.
Jeff, I'll just confirm that we see it. As a reminder, people may want to expand this to full screen, but it's coming through loud and clear.
Okay, excellent. So this is the vRealize Network Insight tool. So the question of how do we actually go through and kind of figure out all these flows and how does these systems actually talk to each other? This is the tool that you would use to actually figure that out. This tool actually has a few use cases, but obviously since we're talking about lateral security, we're focusing on that. This is going to show us how many east-west flows, just on the front page here, how many internet flows. I mean, this is going to show us quite a bit of information. But if we actually want to go through and we're actually wanting to understand how one system talks to another system, all we need to do now is actually kind of go into this planned security piece. And what we're going to do now, what we're going to see is we're going to see all the virtual machines, all the microsegments within my data center. And I'm going to see traffic distribution for all of my workloads. So I can see that in my data center, 78% of my traffic is east-west. So if you're familiar with the old average, the old adage that it's 80-20 or 20-80, et cetera, how traffic flows, we're starting to see more and more traffic from an east-west perspective actually happening with our data center. It used to be 80-20 north-south, and now we're seeing more 20-80, where the majority of the traffic is actually happening from an east-west perspective. And if you think about that in terms of lateral attack, the increase in east-west traffic necessitates, a deeper level of security for those east-west flows within the data center. So I'm looking at VXLAN and VLANs, but I'm going to bounce down to, actually I want to go to planned security, and I'm actually going to select just one of the virtual machines. So I'm going to go through and I'm going to select, I'm going to actually select Prod DB1 here, and I can actually go through and see over the last few days, how much, I can select a specific time period of when this was occurring. This tool actually does long-term analytics over a period of time to actually show me every flow that is actually happening in and out of this system over the last 7 days. So when I hit analyze, what this is going to do is it's going to show me a microsegment, if you will, of this system. We can see that 92% of the traffic for this one virtual machine is from an east-west perspective, and that 77% of that traffic is actually a virtual machine to virtual machine. When I actually swap this down here to by virtual machine, I can now see that this prod DB system actually has several flows to other places within my data center. If I actually click in on this wedge, if you will, what I can see now is I can actually see the services and flows for this system and everything that's been accounted for over the last 7 days. There's been 45 unique flows coming in and out of this system over the last 45 days. These are the services that are actually running within those flows. And if I actually click on the flows, it'll actually show me that this virtual machine is talking to another virtual machine or another IP address, and it will show me the port and protocol in which it's doing so. But here's the key. The key to this is that if you're understanding the flows, this is great information for understanding and helping understand the flows. But how do I dissect this and actually build the rule sets that are necessary to isolate my workloads or segment my workloads? That's where VRNI comes through and says, if I have a recommended number of 30 firewall rules based on those flows of rules to build for this system. It actually gives me the source and destination, the services, and actually tells me the rules to build that will actually accommodate the flows that I've seen over the last 7 days. This is to show that you no longer have to do sniffing. I have to monitor it over a period of time. I have to go back and look at it. This tool actually provides analytics over a period of time to take into account every flow coming in and out of your virtual workload systems, and actually provide the rules that are necessary to contain lateral or east-west traffic from this system to any other system within the data center. This is very, very simple to set up. And going back to kind of that 80-20, rule, if you will, of, what folks are seeing within their data center, this is running obviously in my lab. Don't let me show you lab data. That's what the network assessment is for. I want you to take a look at your organization, work with FusionStorm to get this thing up and running, and actually see what's going on in your data center. This will give you a great idea of exactly how much traffic is actually traversing east-west and where some security pain points might actually be for your systems. When you show this data to security folks, this will open some eyes. You will start to see, I've run these for customers and found, traffic going to the internet or traffic going to systems that organizations never even knew existed. That is kind of the whole key is if you don't know what to protect, then you have no idea what to protect. This is a tool that kind of helps from that perspective. And with that, that's kind of the demo here of how to go through VRNI to actually write these rules. Very, very quickly, I'll show you the NSX interface really fast in terms of how you actually build firewall rule sets. Just a kind of a quick overview here. I have several systems within my environment, and I've built some rules, et cetera. But what we're seeing here is, remember how I told you that we put a firewall at every one of our virtual machine VNICs, if you will, the virtual network card. That's great, Jeff. Thanks for putting 1,000 firewalls on all of my virtual workloads. How do I actually operationalize that? That's all operationalized through the NSX Manager. So if I actually want to write a rule in any one of these places here, it's very easy for me to actually, as you can see, I can actually click on the source. I can actually create groupings and add virtual machine. This is actually a virtual machine. I don't need to know its IP address. I don't need to know any of that information. I just select the virtual machine. I say this source talks to this destination, over the MySQL protocol of 3306, and I'm going to allow that traffic. That's how simple actually writing a rule within the NSX Manager is for actually securing or controlling east-west traffic between these systems. I hope this was informative. I know I only had about 40 minutes or so, but there's a lot more to it. If you work with your FusionStorm folks, they'll definitely be able to take you down the rabbit hole even further long term. Happy to answer any questions.
So Jeff and Rich, we did get some questions. They actually came in through the chat window, which is fine. With that in mind, Rich, I don't know if you wanted to make a commentary about assessments or if you want to do that in a moment. I'll just give you a pause for a moment to give you an opportunity to guide me.
Let's go with the questions first, and then we can address the actual assessment afterwards, if that works for you.
Okay. We've received 3 questions. There's a 4th that came up only from my own experience in prior events like this. And so I'll ask that one real quickly because it's specific to what you just showed. In the example that you showed, there was 78% east-west traffic. And the question I've heard before is, isn't that normal? So why would I care? Why is that a problem? And so I'll just give that to either of you.
Sure. So is that normal? Yes. I'm sorry. So in my previous life at VMware, I was a core SE and an NSX SE, working with customers and doing these types of assessments. And the majority of the time, we did see lots and lots of communication now starting to happen east-west between systems. The reason why this is now more prevalent, right? Because if you take some of the recent breaches where they've come through these low maintenance systems or they've come through a specific VPN, but there's no isolation, if you will, between the workload that they're going to and the next workload that they shouldn't go to. And if those two systems, if you will, think about this from a Windows Server perspective. There's 65,000 TCP ports that could possibly be opened on a Windows Server, right? If you're only allowing port 443 from one server to another, you see how much smaller the attack surface is. It becomes extremely small, which means we're not, so there's no such thing as silver bullet security, but if I only allow 443 traffic to go from one system to another, that's a very, very small footprint of window for me to actually do any kind of attack on. I can't open up a Tor browser or anything along those lines and go across port 80 or open an SSH session or anything along those lines because I'm not allowing that traffic to occur. So if you don't explicitly deny traffic between the low priority system and the high priority system, those systems can talk all they want, technically. And once the low priority system is compromised, it's, they're going to try privilege escalation, and once they find a juicy server, if you will, quote unquote, they're going to try to attack that system because there's nothing obstructing them, if you will, from being able to move from one system to another because the ports are all open. They have the ability to move that way. So when you see 80% east-west traffic, that means that a lot of your systems are talking that way from an east-west perspective or have the ability to talk that way from an east-west perspective.
Very clarifying. So, I'm sorry, Rich, over you.
No worries. I was just going to say, I think you also have to look at layered defense, right? If they breach perimeter, then the next point, as Jeff was saying, is to go after a high-value target. So if we can make that high-value target much more difficult to access, not impossible, but more difficult, then I think at the end of the day, you're trying to stop that communications between those virtual machines. So that's part of what NSX does is that network segmentation on the east-west side of it. The other thing I would say, too, is that if you have that east-west traffic, well, if you don't know what's going on there, it's just like north-south traffic. What is going on from that side? Just the same thing with the east-west prevalent traffic there. It may be innocuous, but you just don't know. And a lot of breaches do happen from an internal inside out. So that's, I think, another key aspect of that as well.
That was clarifying. Thank you. We'll move on to another question.
Some of those systems may not, as they are supposed to operate, They may not need to communicate east-west, but they could be doing something that was never intended for them to do to begin with. You know, I had a customer that found a system running an NFS share off of it, and they had no idea that it was doing it, and it was not supposed to be doing it. So, you know, when you start to see that, it starts to open your eyes kind of to, oh, we've got a lot of traffic that actually occurs from the east-west perspective that may not actually need to occur.
Excellent, thank you. So we'll move on to the next question. It mentions a product. Why can't I simply use a PAN device to control access? I think they mean segment. But.
Sure. So can you use a Palo Alto device to actually do this? Absolutely. Sure. You could do that all day long. There are some limitations to that, right? So that goes back to that east-west or that virtual firewall perspective. That virtual machine, and you can steer all the traffic you want to it, but it's going to be constrained by being a virtual workload. With vSphere, with NSX, the firewall is in the hypervisor, which means we run in kernel, which means we get kernel rate performance for each one of those firewalls, if you will. As you add a workload, you add more kernel firewall level performance. We're seeing somewhere around 19-ish gigabits per second per host out of that firewall. A PAN device will not be able to hit that level of throughput through a server's virtual machine. It will also become exceedingly difficult to try to write all your rules. They do have Panorama, which is a great tool in terms of being able to write rules, but it will become exceedingly difficult over a period of time. Which device do I need to go into? Which, you know, oh, I got to go over here. It's when you go into one kind of place to actually write all these rules, it becomes a little bit easier. Now, what I want to stress is, remember we're talking east-west. I'm not trying to dissuade you from using Palo Alto if you need it, but what I am saying is, if you only want to look inside 443 traffic from web to app or from the outside into the web server, you can absolutely pump that to a Palo Alto device and actually do the deep packet inspection. But you may not need to do the deep packet inspection from the web to the app box or the app to the database server. So don't do that from a Palo Alto perspective. Leverage NSX to just do the bulk, if you will, bulk firewalling from layer 2 through layer 4 or the other flows. That way you're reducing the amount of basically the need, if you will, or you're reducing basically oversubscribing kind of that Palo Alto VM on the host by sending everything through it.
Yeah, I think that's a good point. So, Rich, I'm going to throw this to you for just a second because I know from personal experience that you have done integration with Palo Alto Panorama and NSX microsegmentation. Did you have anything to add to Jeff's comments?
Yeah, I think, you know, if there's an integration requirement there, the Palo Alto also provides IPS IDS where the NSX doesn't have that capability as of yet. So, I mean, there's a natural integration there as well. So, exactly what Jeff said, I think the biggest concern is depending on bulk, you know, reviewing bulk payload there. It's a point, you're at 0.5, you know, maybe 500 megabits, 1 gigabits, or even 2.5 gigabits, depending on the version of the virtual Palo Alto. Even though those numbers may be higher, typically when you're looking at deep packet inspection, you kind of cut that number by 50%. So with the NSX, we're roughly, like Jeff said, 19 gigabits per second. Pretty impressive performance there. So for those reasons alone, I'd look at it a little bit differently. But again, if there's an integration requirement, you need that IPS IDS, and the Palo Altos are great.
Okay, yeah, I want to make sure that folks understand that Palo Alto and VMware have a great partnership and relationship, and we absolutely, if you need that layer 7 inspection, you know, they're a great you know, partner to work with in terms of that. The integrations between the two platforms are pretty extraordinary.
Terrific. So let's, in the interest of time, I'll jump to the final question. Well, actually, there's one other, but we'll go to a quick one. Rich, I'm going to throw this at you. The question is, we are using VDI, which is virtual desktop infrastructure. Why would I also need segmentation? Kind of an interesting question, sort of suggests that VDI is already secure.
Yeah, actually, that's a great question, and I think at the end of the day, VDI is not secure. And I look at different groups that have different, say, personas. You know, whether it be, say, HR as compared to, maybe the production floor, or from a back office area perspective. Finance, for example. So I think NSX comes into a natural play there, allowing us to break it up from that perspective as well. Not only can we give them different images, different personas, we talk about profiles, but we can also take care of it from the networking perspective. There's a natural integration between the two. So again, I get it. One of the key benefits of VDI is being able to create that image. If there's a problem, you strip it and create a new one. And that's how you typically would get rid of a problem corruption, or say even a ransomware attack is we provision it. But I think at the end of the day, we're missing the vital infrastructure, the networking side of that, without looking at the NSX side of it. I'd hand it over to Jeff to see, Jeff, what do you think about that as well?
Yeah, so I think there's, I touched on it a little bit before, and if you think about things from a grouping mechanism, if when you build desktop pools, they're all kind of named the same or very similar. You could leverage NSX to basically say any machine that's named, desktop X or whatever you want to call it, actually place it into a security group, which means that, we could say that this security group can't talk to this security group, which means with one rule, we functionally said the desktops can't talk to each other. Very, very simple. And remember that, if we're talking about containing lateral attacks, right? If one desktop is compromised, it's very easy for them to move to another desktop and compromise that one, et cetera, et cetera. But if the desktops can't talk to each other, it becomes very easy to contain, kind of those, contain those attacks. There's also some other things that we do from an NSX perspective for VDI desktops. So agentless AV integration and offload. And then the ability, obviously, to protect the management infrastructure of what actually builds those desktops.
I love it. Well, I do have one other question, and maybe there's a really quick answer. It came in, our database is not virtualized. Can I block access from VMs?
So absolutely. So from VMs, yes. So the way that I can control traffic from an NSX perspective is I can control virtual machine to virtual machine traffic. I can control virtual to physical. So I can say that these virtual machines can talk to this IP address. So remember, in a physical world, I don't have any visibility into that physical world, if you will, from an NSX perspective, but I can create what's called an IP set and say that if your database is 10.0.0.2 or whatever, that these virtual machines can talk to that IP address over this port and protocol. So I can limit or just basically say that these systems can't talk to that system, regardless.
Terrific. Great, great, great. Yeah, and I think the question was focused on blocking access, which is what you just said. Now, We're running a little bit short. We've got a few minutes. Rich, let me just double check. Are you seeing the screen that's on with the assessment?
I am, and this is one of the things that we want to do from a FusionStorm perspective in conjunction with VMware. Is one of the things we're offering our customers is a virtual network assessment, or a VNA. And feel free to look at this and sign up, and we'll be happy to go in and work with you to basically deploy that assessment and give you that information and look at it, and we can run through what the results are. Obviously every environment is unique, and so one of the things that we do from a consultancy perspective is we'll look at that information with you, go through it, and give you an idea of what we're seeing, and potentially, number one, is your network, what's going on east-west, and also is your network prepared for that next level, for, in this case, the software-defined networking with NSX.
That's terrific. I was scrolling on screen here, and I see that you have a total of 5 different assessments available. You know, and people can certainly contact you to find out timing, if there's any cost associated with it, and what's involved, certainly prerequisites, et cetera. One thing that I did take a moment to do was call out the URL. Let me just zoom this in, just so you can kind of, so end users can see the URL here. Whoa, sorry about that. I'm not doing a very good job. I just realized. Sorry about that. Let me actually. So there it is. From a FusionStorm link on partner demand, you can see this URL. My presumption, John, I'll throw this action item to you, is that this will come out in the follow-up email where people can get this URL and request an assessment conversation from your team. Now, with that in mind, I think I just want to take a brief moment and say thank you, first of all, for the participants who joined us. We will be closing out the webinar at this in just a moment. But more importantly, thank you to Jeff and to Rich for really useful content. I think I speak for everyone in saying it's appreciated. So with that in mind,
thank you, everybody.
You bet. Thank you, everyone. We'll go ahead and stop the recording and get back on track. Thanks, everyone.
Thank you.
Have a great day. Thank you.